Hello, today we're looking at logistic functions. So I created this here. So we have the graph of the function. Our function is here and we're exploring parameters A, B, and C. So A, B, and C. So let's take a look at A first. And A controls the horizontal asymptote of the function. So the function moves up and down. It creates a ceiling for this function because it is up in this numerator here. So the x values don't directly affect or change A. So the limit of this function as it approaches infinity puts the bottom value right here at 0. So then that means that the limit is just going to be this A value. So it's the horizontal asymptote of the function. So let's set that at 1. And let's take a look at B. So B changes the movement of the graph from left to right. And it seems as we get less than 1, then that change happens faster. So it doesn't affect how quickly the change happens, it just affects where it happens along our x-axis. And that is because it's right here in the denominator of our function, and it is multiplied by our base and our exponent here. So it is, when you look at exponential functions, before we look at a logistic function, that number right there in a normal exponential function would simply change what the shrink or stretch, or what they call compress now as well, compress or stretch. So that is why that happens. Let's set that 1 to 1 as well. And then we can look at C. Sorry. If we look at C, C is our rate of change. C is how quickly that rate of change happens in the graph. And as once C is equal to 1, we have a straight line. And when we change these, it just moves where that line is on the graph. But when C is equal to 1, it's a straight line located somewhere above the x-axis. But as C becomes less than 1, then it changes to a decay function. And as it's 0.9, it is a very long change. It happens over a long period of time, over an extended portion of x values. And as it gets closer to 0, that rate of change in the decay happens much quicker. So whereas a positive value, the closer to 1, and then the farther we get away from 1, it gets quicker. As a growth function, decay is the same. So as it's really close to 1, that decay happens very slowly, but as it gets quicker, the rate of decay, the rate of change for this function happens much faster. So if we were to look at a function here that is h of x is equal to 2 over 1 plus 3 times 0.5 to the negative x. So right here, as we discovered, is our rate of change in our graph. And so the rate of change, if the rate of change is less than 1, then it is a decreasing function, it is a decay function. And if our rate of change here is greater than 1, then it is a increasing function, or it is a growth function, is also another term for that. And when it is equal to 1, it is a straight line or it's linear. So, and this 2 is our horizontal asymptote. So this function we would call a decay function, because we discovered what this rate of change does and what this looks like in a graph before. So we've done that exploration and we know now exactly what this value will produce. So we can test that and turn the graphics back on and we'll turn this off. We'll turn on our graph and look at that. So horizontal asymptote at 2, and it is a decay function or a decreasing function because it is less than 1, as we discovered in our previous exploration. And I can turn that off, turn that back on. And as we can see, even in the decay, the B value changes where on the x-axis, and the A value changes the horizontal asymptote. So our ceiling on our graph, the highest value it can possibly be, and that is all I have to show for today. Thank you for watching, and goodbye.